Hello. So today I'm going to be going over a board very quickly that was having issues with fan control. So fans running on high is a common issue, and one of the things that drives me nuts, as you're probably familiar with if you're familiar with me or this channel, is when people ask me what chip controls the fan, what chip controls fan speed. And see, and questions like that drive me into a mad frenzy because they show a lack of analytical thinking and problem solving. You don't get to just not think and solve the problem. You get to not think and solve the problem if you fix iPhone screens. You get to not think and solve the problem if you're reinstalling Windows. You don't get to not think and solve the problem if you want to do motherboard repair at component level. For that, you must think. And that is what I am trying to teach to do with this channel. So, one of the very, very common issues that you get on a lot of these machines, especially after a liquid spill, is that the fans are running on high. Now, there are several different reasons for that, and today we're going to go over a simpler reason, but a much less common one. Usually the fans are running on high because the machine's sensors are not reading properly. So you run the Apple service test and it tells you that one of the sensors is not reading properly. So it'll think that the CPU is using much more power than it is, which will cause the fan to spin up. Or it'll think that the temperature is much higher than it is, which will cause the fan to spin up. Or it'll cause it to run slow because it'll tell it to send less power to the CPU, or any one of those things. And the only test that failed in ASD today was motor control for the fan. So even if you don't know what motor control means, you can simply Control F in your schematic and search for motor control, and you'll find this page. And let me tell you, you do not need a 4K monitor to view this page. This is nothing. This is nothing. And also, as you can see here, my laptop with integrated video very much so protests me doing live recording from this camera while asking it to smooth out the text in a PDF file. So it doesn't like that one bit. But let's see what we can get going here. So this is the fan circuit, and again, this is fairly simple. So you have 5 volts DC. We know what that is. That's power to power the fan. Then we have TAC, fan RT TAC. I don't know what that is, and I honestly don't care. We have motor control, which is, I'm guessing, controlling the motor of the fan, which is where my fault probably lies, because that is the test that failed in ASD. And we have ground, which is ground. And then we also have not connected here, number 6, which is really, really weird because this is a 4-pin connector that has no 5th or 6th pin. So I'm just going to assume that whatever Apple engineer put that there was probably on crack at the time, and I'm going to disregard it. So over here, we have a 47 kilo ohm resistor. That tested fine. Again, I figured that would test fine. We have this 47 kilo ohm resistor. I also figured that would test fine because, again, that's not part of my problem. And then we have this 100 kilo ohm resistor on the motor control side of the circuit. That 100 kilo ohm resistor here was only 2 kilo ohms, which is part of my problem. So I replaced that resistor with a 100 kilo ohm resistor, and it still didn't work. So now here's where the analytical thinking comes in. And again, in a circuit this small, you don't need much analytical thinking. Now this resistor is between PP3V3 or 3.3 volts and the source of this transistor. So if this resistor got fucked hard enough that it is now 2 kilo ohms instead of 100, it must have had something really bad must have went through here. And the only place that it has to go after here are 3 places. The first is the fan. I tried a new fan, it didn't work. The second is this transistor. The third is the scary part, SMC. We really don't want that to go to the SMC because this chip is like this small, and I'd show you on the microscope, but I'm just about to leave and my microscope camera's acting up, and I really just kind of want to go home. But this here is a chip. The SMC is a chip with all these little balls under it. It's not marked in the motherboard in any way, so it's very easy to misalign properly and destroy the entire computer if you fuck up this chip. So I was hoping it wasn't that. Or this little transistor with 3 legs that, that a monkey can replace. Even me. So I replaced this. And now the fans don't spin on high anymore. So that was a very simple solution to a very simple problem. And I like problems like this. I like when I don't have to run wires all over the board or stay here until 1 in the morning to figure it out. It's really cool when it actually is very simple. It's very laid out. And it just makes sense. And again, you don't have to know what everything means in order to solve your problem. Again, do I know what TAC means? No. I mean, there are probably people who are going to comment here going, oh my God, you don't even know what that is. And you know what? It may be something very simple. And I don't care because I didn't even have to Google it to figure out my problem. I was simply able to use common basic sense to solve the problem. Again, this isn't even electronics common sense. This is just common sense? If this got destroyed by the power that went through it, is it not common sense that the thing right in front of it may have been destroyed as well? And if this over here still works, so if my fan still works, is that not common sense that it must be something between here and here, which is this, that's broken? Worked for me. Hopefully you learned something.